All right, we're going to look at one last example here to wrap up this section and just kind of recap all of the ideas that we've discussed so far. So it says the National Sleep Foundation conducted a survey on the sleep habits of randomly sampled transportation workers and a control sample of non-transportation workers. The results of the survey are shown below. So we've got all of our different types of transportation workers. Remember, our control group is the non-transportation workers. We want to conduct a hypothesis test to evaluate if these data provide evidence of a difference between the proportions of truck drivers and non-transportation drivers, which is the control group, who get less than 6 hours of sleep per day. We are going to use a significance level of alpha equals 0.1. So, as we start, the first step is always to set up what is our hypothesis. What does that look like? So let's make a decision right here at the beginning of our problem, which of these groups is going to be group 1 and which is group 2. Just for the sake of ease, let's call the control group group 1, and the truck drivers, we'll go ahead and call those group 2, because we want to talk about truck drivers and non-transportation workers, which is the control group. So, all right, we can do it that way, or we can say, P sub C is the proportion of control groups, or the proportion of the control group, and the proportion of truck drivers, we could call that P sub T. Maybe we'll do that instead. So, I need to start off first, getting ahead of myself here, with what is the null hypothesis? What's the null hypothesis? And what's the alternative hypothesis? That's my first step. So I would like to know my null hypothesis is remember, that's always the same. That never, ever changes. So my null hypothesis will be P1 is equal to P2. If you want, you can also label that as P sub C for the control group and P sub T for the truck drivers. Either one of those two things is fine. Again, if you're using 1 and 2, just make sure you make it clear to me which one is proportion 1 and which one is proportion 2. So if that's the case, we'll go ahead and keep going. Our alternative hypothesis then, we wanted to test if there was a difference between the two groups, which means it's not a left-tailed test, it's not a right-tailed test, it's a two-tailed test. So my alternative hypothesis will be P sub C is not equal to P sub T. So I've got my null hypothesis, I've got my alternative hypothesis. I do also think at this point it would be extremely helpful to start gathering some information. In particular, I would like to know what is P hat 1 and what is P hat 2, because we're going to use those in our hypothesis test. We're also going to want to know what is P hat pooled, because we need to use that to check our conditions. So P hat 1, let's call that the control group, and P hat 2 the proportion of truck drivers here. So for my control group, we said we had 35 workers with less than 6 hours of sleep out of 292. So 35 divided by 292. So if I go ahead and divide that out, 35 divided by 292, I end up with 0.1199. I'm going to round to 4 decimal places just to be safe here. And the proportion of truck drivers that get less than 6 hours of sleep, well, we have, once again, 35 of those individuals and 203 total truck drivers. So 35 out of 203. So 35 divided by 203. So if I divide that out, this time I end up with 0.1724. Again, rounding to 4 decimal places just to be safe. I also want to know what is P hat pooled. So P hat pool, remember we're combining these two things. Essentially, we're just going to be adding our numerators and adding our denominators. So we're going to take 35 plus 35 divided by 292 plus 203. So let's see, my numerator should be 70, and my denominator 292 plus 203. Here I end up with 495, and if I divide those two, divided by 495, I end up with 0.14 repeating. So 1414. So there is our p hat pooled, or simply just p hat. So at this point, I've gathered all of my information. If you want to make other notes, like what is x1 and what is n1, but those are included with your p hat 1 or p hat sub c in this case, and p hat 2, which is p hat sub t in this case. So we've got basically everything we're going to need through the rest of this problem. So we've set our hypotheses and we've gathered some information. The next step then, step 2, we want to check our assumptions and conditions. Remember, the first thing that we want to check is, do we have independent sampling? Independence. So in this case, if I go back and look at this, do we have independence? We're going to use randomly sampled transportation workers, just a random sample here in this case is kind of a substitute for that. So yes, we do have independent sampling, and then we want to check our success failure condition. So remember, since we have two separate sample sizes, we're going to have two separate success failure conditions, 4 of them altogether. So I need to check n1 times p hat, n1 times p hat, is that greater than or equal to 10? N1 times 1 minus p hat, is that greater than or equal to 10? And then the same thing for n2. We said group 1 was our control group if I go back up here, and our sample size for that group was 292. So I'm going to take 292 times our p hat, 0.1414. This should not give us any trouble, but we're going to go ahead and verify. I ended up with 41.2888, which is greater than or equal to 10. So yes, that one is met. And then n1, which is again 292 times 1 minus 0.1414. And this time around, I end up with 1 minus 0.1414, 250.7112, which is greater than or equal to 10. So yes, that one is met. So we've checked our success failure condition for the first sample, but of course now we have a second sample to consider. So I'm going to take my second sample size, which I've got to go back and look at. Our group 2 was the truck drivers, and our sample size there was 203. So our N2 is 203. So we want N2 times P hat. Is that greater than or equal to 10? So 203 times P hat, we said that was 0.1414. So grabbing my calculator real quick, 203 times 0.1414, I have 28.7042. That is certainly greater than or equal to 10. And then, of course, I want N2 times 1 minus P hat. Is that greater than or equal to 10? So 203 times 1 minus 0.1414. So 203 times 1 minus 0.1414. This time around, I end up with 174.2958, which is greater than or equal to 10. So we have independence, and we at this point have now verified our success failure condition. So that's awesome. That means that we can continue on. Again, remember, this is not something that I'm usually going to try and trick you on. I may ask you to verify these, though, on quizzes and tests, in particular that success failure condition. So make sure that you feel comfortable with that and you know how to find, say, for example, P hat pooled, because that is still something that we're going to need. Excellent. So that means we're ready to move on to step 3. Step 3 is when we're going to go find our test statistic and our p-value. If you want to calculate these by hand, you certainly can. This is generally not a step that I'm going to recommend doing by hand in these types of problems because it was quite lengthy. So just to see what that process looked like on our graphing calculator, remember that we're going to need some information. We need to know In this case, what is our alternative hypothesis? So we're doing a two-tailed test here, and then we need to know x1 and n1 and x2 and n2. If you found your p hats at the beginning of the problem, it should be all set. We're just going to be using those. So I'm going to hop over to my calculator here real quick, which is right here. Let's go ahead and jump to the menu that I want. So remember, to get to this hypothesis test, if we press stats and we arrow over to the right 2 times so that we're under tests, and then we're going to choose option number 6. You should see 2 prop z test or 2 proportion z test. So that's what I want. I'm going to go ahead and press enter. And then I'm going to go ahead and enter in this information. So our x1, the number of our control group that got less than 6 hours of sleep. There were 35 of those individuals. N1 is the sample size for the control group, which we said was 292. X2, this is the proportion of truck drivers that got less than 6 hours of sleep. That's 35. And N2, that's the sample size from the truck drivers, which is 203. We want to make sure that we have chosen the correct type of test. In this case, this is a two-tailed test, so we want to make sure we have it set to not equal to P2, so that's good. And then at that point, again, you can go down to either calculate or draw. All we really need from this is the test statistic and the p-value. Those are the 2 things that we're most interested in finding. I'm going to go ahead and click draw just because I like to see what that p-value represents here. So in this case, the p-value, or excuse me, the test statistic is on that left-hand side. Remember, our test statistic is that z-score of negative 1.6504, and our p-value is that value in the middle, p equals 0.989. So let's go ahead and hop back. The other thing that I think is helpful for these types of problems is to just make a quick note about what calculator function that we used. So in this case, we used a 2-prop z-test. And this is helpful because for these types of problems, I can't really check your work if you're going to be using a graphing calculator, and if you give me the wrong test statistic and the wrong p-value, saying that you used your graphing calculator to find them, there is no opportunity for partial credit here. So we want to kind of try and show whatever work we can for these, and in this case, we're just at least going to write down the calculator function, and then if you end up with you use, say, the correct calculator function, you used 2-prop z test, but you ended up with a different p-value and test statistic, I'll know you probably made a typo, or maybe you chose the wrong type of test, or whatever it is, and I can at least give you some credit because I can see that you were using the correct graphing calculator function. So this is a 2-prop z test. My test stat, we said is a z-score. Z is equal to negative 1.6504. We'll go ahead and round to 4 decimal places because that's what we've been using throughout this problem. So there's our test statistic, and then of course our p-value, the thing that we're going to use to help make our decision. Our p-value this time around is 0.0989. So there is our p-value. These are the 2 things that I'm going to be looking for. These are generally the 2 things that are most helpful for us towards the end of our hypothesis testing problem. So that's wonderful. We have our test statistic, we have our p-value, we have everything we need to make our decision. So remember, in step 4, we are making that decision, and then we are interpreting that decision in terms of our original problem. So in this case, our p-value was 0.989. It helps to compare that to alpha, which if we scroll back up and look at it, we said up here, alpha was 0.1. So in this case, alpha is 0.1. So the question that I ask myself, is the p-value less than alpha? In this case, yes, it is. The p-value is 0.0989. There's a less than 10% chance of getting a getting a sample like ours, assuming that the null hypothesis is true. So Because the p-value is less than alpha, that means that in this case we are going to reject H naught. So we have chosen to reject H naught, which means that there is enough evidence to support the alternative hypothesis, which if I scroll back up, we said that there is a difference between the proportion of truck drivers and non-transportation workers who get less than 6 hours of sleep. So we're going to kind of try and summarize that as best we can. There is enough evidence to support a difference in the proportion of truck drivers and non-transportation workers that get less than 6 hours of sleep. Less than 6 hours of sleep per day. So